Okay, so determine the resultant force on each of the following objects and show its direction of motion. So in this case here, we have got 20 newtons pulling that way and 10 newtons in the opposite direction. Okay, so clearly there's more force going this way. Okay, so it's going to be moving to the right, yeah? So to get the resultant force, you need to look at the sort of leading force, which is 20, subtract then the resistance, which is 10, and you just end up with 10 newtons. That's the resultant force, and it'll be moving to the right. Okay, in this case here, well, we've got two forces pulling to the right, so if you add them up, that'll be 7, and then take away then, well, you've got 6 then going to the left, so it overcomes that 6, doesn't it? Okay, so even though you've got a resistance of 6, you've got 7 pulling this way, so it still moves to the right because you've got a resultant force there of 1 newton and it moves to the right. In this case here, well, we need to add all these up here. Okay, so 31 add 20 is 51, add 27 is 78. Take away then these two, add it together, so that comes to 81. So you get minus 3 there, newtons, okay? So because we sort of thought of going to the right as positive, you end up with a negative answer, which means that actually it's going to be moving to the left, yes? So we can say the resultant force is 3 newtons. So we get rid of the negative then, we can say 3 newtons, but it moves to the left. Okay, that's the resultant force. That's the effect of these forces combined. This here is greater than this, okay, by 3 newtons. In this case here, resultant force, so we've got 11 newtons to the left, and 9 and 2 is 11 newtons to the right. So that actually comes to 0. So the resultant force is 0 newtons. Now in this case, we can't actually tell which direction of motion is going. It could be stationary, okay, whereby it's not moving at all, okay, or it could actually be moving, okay, as a result of Newton's laws, okay, it'll just be moving at a constant speed, so we can't tell in this case. So the resultant force is 0 newtons, so it's either stationary, as in it's still because the forces are balancing each other, or it is moving but at a constant speed. In this case here, body is at rest when subjected to the forces shown in the diagram. Find x and y. If it's at rest, that means x has got to balance with this here, so x has got to equal 60 newtons. Okay, opposite directions have to balance, and the same here then in the vertical direction, okay, or this direction here. We've got 50 newtons going that way, so in that case then y has got to be 40, isn't it? Because this has got to add up to 50 as well, because the opposites have got to balance, so that would be 40.